is more intermittent in nature, and it's not easily controllable. So if you have a lot of fossil-based generation, you don't need a lot of flexibility.
Okay.
Yeah,
You have it.
that's the reality. Yeah, I'm giving you guys straight. Yeah, that's how it is.
Okay. Yeah. There we are. Wow. Perfect. So, welcome to a new episode of Energy Bridge. We are here with Bharath inside the AIT, Austrian Institute of Technology.
Yeah.
In the smartest lab.
In the smartest lab. So, I don't know you, but I feel like a kid in a, in a playroom, like making so much tests. We're going to try to shoot something here and there. So yeah, welcome Bharath. Thank you for giving us this time, and we're very excited to know about your work.
Yeah, thanks for having me, guys. Yeah, you're welcome to AIT.
Amazing.
And the smartest lab.
Hey, but before we get into your career journey, could you explain this place a bit?
Sure, yeah. So AIT has quite a lot of laboratories, and this is one of the biggest ones. So this is called the Smartest Lab. So Smartest Lab was mainly designed as an accreditation laboratory for providing test reports for, at the beginning for inverters, but now we've branched out to not only inverters, but electric storage systems for electric vehicle charging stations, and so on and so forth. We also had a microgrid set up here a few months ago to test the viability of a microgrid. So this is a commercial laboratory, which means that our clients come to this lab, and then they bring their devices, and this is an entry point for them to sell their products in Austria. So they need to get certified, and AIT is one of the very few certifying, or AIT provides test reports, and then they can later go and get it certified to be able to sell their products in Austria.
And you told us about that place that this is the Klima...
The Klima chamber, yeah.
Klima chamber.
Yeah, so the test specifications requires the device to operate in certain environmental conditions, and then we can test that in the Klima chamber. So we can have varying degrees of temperature, humidity, so on and so forth, other weather parameters. And we can connect the device on load, so that's important. So the device are actually functioning, so it's on load, and we can vary these temperature profiles to get different parameter characteristics, and we can see that and make sure that the devices adhere to the standard.
Amazing.
So that's the main focus.
Now we can get into your journey, Bharath. So tell us about yourself a bit. Where you're from? What did you study? And how did you end up in a Klima chamber?
I am a researcher right now, so I'm a scientist as well as business developer at a department or group, or we call it a competence unit. It's called Power and Renewable Gas Systems. And I moved to AIT approximately 10 years ago. I came here to do my master thesis. And before that, I was studying my master's at Grenoble INP in France, in Grenoble, in the middle of Alps. And before that, I come from India, from Bangalore. So I studied my bachelor's in electrical engineering from Visvesvaraya Technological University in Bangalore. And it's been a hell of a journey. Yeah, and right now, 10 years in Austria. Before that, in France, and then I'm originally from India.
Okay, and how old are you? You have done a lot.
Yeah, I'm 33 years old. Yeah, and I got my PhD 4 years ago. And it's very interesting to work at AIT and looking at all this amazing infrastructure. Meeting a lot of interesting researchers across Europe, and I coordinate European level projects. I get to travel a lot, meet incredible researchers across the European continent.
And a bit more about your subject of study at the PhD. And so you started doing your PhD. You did your master thesis at AIT,
and
then you continued doing your PhD.
Absolutely, yeah. So my master thesis was on data-driven methods for customer profiling, basically. So we have quite a lot of data. I mean, this is 10 years ago approximately. So we had a large-scale installation of smart meters back then. In France, there was a very big push for Linky smart meters, as you may know. And in Austria as well, the smart meters were coming up. They were being installed in Austria, and the regulator, E-Control of Austria, wanted to know if it's possible to get the forecasting accuracy lower for mainly retailers to better manage their portfolio, and then they can go to the market with a better forecast and better portfolio. And that's the reason I was aggregating different profiles of different types to help retailers do better load forecasting. So that was the focus of my master thesis, and then for my PhD, I moved back to my roots, which is power system, to do a very detailed power system control implementation. So mainly control for low voltage distribution grids. So doing a lot of load flow simulations, optimal power flow. I developed a method to manage flexibilities in distribution grids, and then this evolved into local energy community control, because as you may know, in 2018, or was it 2019, European Commission adopted the clean energy transition as a clean energy partnership. And the clean energy package of the European Commission first created local energy communities, the concept of local energy community. And that really blew up in Austria, and Austria was one of the very first countries to adopt this and transpose
we
it
have
to...
seen a lot of developing in this area. So you have been here 10 years so far, and we are in a very exciting and fast-growing industry. What changes have you seen in these 10 years researching?
Right. Yeah, I mean, the biggest change would be digitalization.
Okay.
So in the last 10 years, digitalization has gone into every single domain, because traditionally power system is a very conservative domain, and there's nothing really happened for the last, 100 years. And then in the last 10, 20 years, everything changed. Wow. Because you have the invention of the smart grids. So smart grids started, coming into forefront because we are installing, or we have a desire to install a lot of renewable energy in distribution grids, again, because of the climate goals that we have, and this poses a lot of challenges.
Could you tell a bit more about what exactly we mean by smart grid?
Absolutely, yeah. So the desire for us, for Europeans as well as across the world, is to minimize our carbon footprint. So we want to electrify most of the traditionally carbon-based loads. For example, you don't want to transition from heating using renewable, or using gas, for example, or wood or coal. You want to transition to electricity, because electricity, we can make it more green, and we can make electricity move away from carbon-based generation, like coal power plants, diesel power plants, for example. So our goal is to make it more green, so we have more renewable energy, that is solar. We want to have more wind, for example, and this poses a lot of challenges. And that's the reason we want some intelligent way to manage these challenges that comes up with this renewable energy, because you can't predict solar very accurately, you can't predict wind very accurately, because wind is blowing whenever the wind wants to blow, and that's the reason there is smart grids. So it's an intelligent way of controlling different assets within the grid, so that there are concepts like self-healing, for example. If there's a fault, then there are algorithms which automatically heal the grid to restore the electricity to the customers and minimize the blackout time, for example. All of these things are smart grids.
Amazing.
So it's smart grid is a concept of coordination between assets in a sector, load, generation, and how to manage the balance. How important is the storage in this concept?
Absolutely. So we're producing a lot of energy, and this is renewable energy that we're talking about. So it's important that we utilize it as much as possible. Because if we have too much renewable energy, so we saw this a few weeks ago, or was it last week in Spain, and in the Iberian Peninsula. So we have a lot of renewable energy that's being produced. So we want to efficiently utilize it, because it's a shame to curtail it.
Exactly.
So we don't want to curtail solar power, because there is quite a lot of solar in Europe right now. So during midday, when the sun is at the highest in summer, there's so much solar production that we won't be able to consume it.
Yeah.
And then right now we're curtailing it, and that's a shame, because you have such a large infrastructure of solar energy, and we don't want to waste it, and that's the reason batteries are important, but batteries are beyond that. So it's not just storage. Batteries can also support the grid. Batteries can help customers manage their renewable energy production, their loads and their consumption in general. And it can also support the distribution grid or transmission grid to provide some kind of services to the grid. So they're more than that.
Just one more thing. It's let us know if it's related or not, because we saw last days, we are 13th of May recording this, and the day ahead market showed prices near to minus 500 euros per megawatt hour. Is it related with the production of renewable?
100%, yeah, because there is a concept called merit order at any market that you're looking at. So for example, IPEX day ahead market. So the concept of merit order is persistent in all of the markets. Of course, there's a lot of discussion about this needs to be changed and so on and so forth.
We're going to make an episode just for that.
Exactly, sure. Great. Yeah, so the concept is very simple. You want to give priority to the generators, which is the cheapest, because you want to keep the generators that are cheapest to be able to produce more electricity, so that it's cheaper for everybody. So which is the cheapest energy in Europe right now?
Solar.
It's solar.
Wind.
Solar and wind. That's the cheapest. And the concept of load and generation. So there's an intersection at a point. So it's there's also this concept in merit order where there's an intersection. Everything beyond that point, so it's called the market clearing point. Everything beyond that point is not considered in the market action. Everything below it is considered. So if you have a lot of solar production and wind production across Europe, so all of these are very cheap. And then that's the reason for example, the thermal power plant, which is very expensive to run and which cannot be turned off very easily. It's at the end of the merit order, and they need to make it cheaper to be able to participate in the market. So if they go beyond the market clearing price, they're out of the market, and they'll have to shut down. So for them, it's more expensive to shut down and come back again next week or next day. Than
the heating system.
Exactly.
Process,
it's more expensive, and that's the reason they offer a negative price. So they're willing to pay you to be connected.
Okay, so this is a parenthesis because we want to go into your research. But thank you for
that. Also about just adding to that, and it addresses grid and the stability of the grid, how more and more renewable has to be integrated within the grid. And you're working with digitalization, with the ML model for the grid, and with the smart grids. How important it gets more and more, because we are in Vienna, the grids are slightly modernized here compared to the Eastern Europe, and they have a, let's say, quote unquote, somebody said, shitty grid. Why it's so important for them to integrate smart grids then?
Right, absolutely. I mean, now because there's so much diverse set of loads and generations that are connected to the distribution grid, it is impossible for DSOs to manage this, because there's one main issue is observability. So distribution grids are not observed. So the smart meters that are connected, especially in Austria, due to GDPR laws and data protection laws, it cannot be used by a DSO to do some kind of real-time control. It's not allowed. So the distribution system operators are not allowed to use this data for network planning as well as real-time operation.
What are the hurdles for that? Like why?
It's data protection, because you can know quite a lot about your personal behavior. Like, for example, if I have your profile, your apartment, for example, your consumption profile, I can say a lot about what you do in the house. I can say when you watch a TV. I can say when you're taking a shower. All of this is possible.
Is it like considered personal data?
It's personal data. Okay. So your consumption data is personal data, because it gives a lot of information about your behavior, and it's rightfully protected. It needs to be protected. It's rightfully protected. But and that's the reason DSOs, at least in the current regulatory environment, they're not allowed to use this data in real time. And that's the reason we have developed some AI methodologies to be able to predict at a rather high accuracy with a subset of these measurement devices. So we don't have full observability. We can have few measurement devices strategically placed in a distribution grid to be able to predict everything else
like
in the distribution grid.
Aggregated data with many consumers.
Exactly,
Not one by
no,
one.
But we can also do one by one. So we just need to have a certain number of smart meters connected from the DSO or from the customers who are willing to provide this data to the DSO. So with the help of this, we can predict everybody else in the distribution grid. So this is one example where digitalization as well as AI applications helps in grid management, because observability is the biggest hurdle, and we're trying to solve this observability issue.
Okay. And you worked on a project called Grid Cloud.
Yeah.
What exactly was the project, and how did it apply to the topic that we have just touched on?
Absolutely, yeah. So Grid Cloud is a European initiative. So it's funded under Aeronet funding instrument, part of the EU. It's a transnational funding scheme, and the main focus of the Grid Cloud project is digital twins, to enable digital twins to support grid operation. So that's the main focus of the Grid Cloud project. So we have different countries part of the Grid project. We have actually 3 countries. So it's Austria, Germany, as well as Turkey.
Yeah.
So we have different use cases that we are addressing in these 3 countries. So I think the most interesting one right now, especially with the climate change, is the Turkish use case, where
Why so?
Yeah, because there's this area called Karaburun. So it's a peninsula in Turkey, in Izmir region of Turkey on the Mediterranean, like right across Greece, and they're experiencing quite a large number of storms and weather events.
Yeah.
And that's the reason you have this transmission poles, right, which is carrying cable because they're overhead lines in Turkey, and they're being affected. So a lot of them are just falling off.
Because of the heat?
Because of the storms.
The storm.
Extremely high wind conditions, rain, hail. Because of that, the cables are being affected, and then the poles just drop because it's so windy, because it's the Mediterranean, and it's extremely stormy weather. And we want to be able to predict this, that it's going to happen somewhere, I don't know, in the next 24 hours, with weather data, with electrical information that we have, and also historical data, so that the crew who's responsible for fixing this issue can already preemptively start driving, or they're ready that this is going to happen, and they can go and they can minimize the blackout time so that our customers are not affected for longer than they should be. Yeah, that's the focus.
And what we were talking just before we started shooting about how exactly these fundings and how these projects work within AIT.
Yeah.
If you could just tell us a bit more about the structure of projects that are under AIT, how are they funded, and who are the stakeholders?
Right. Yeah. So AIT gets 1/3 of its funding from funded projects, so which is, for example, national level funding, FFG, so the Austrian Research Promotion Agency, is one of the funding agencies that funds projects. Again, this is like a public call that we as AIT, a research institution, we partner up with our large network of partners. So we create a consortia, and we come up with a very nice proposal. We submit to this, and then we win this proposal.
Who are the partners that AIT work with industry? And
yeah, we have partners from industry, from public organizations, from all sorts of life. So because we are doing such a complex project right now, so it's not really focused on one industry anymore. So it's more sector coupling, and we are focusing on social scientists, for example, universities and institutions that focus on social science. They're also part of the project, so it's quite broad at the moment. So it's a sector coupled solution. So this is one funding agency that we apply for funding to. Of course, the European Union. So we have the Horizon Europe funding instruments, LIFE, of course, the CTP, Clean Energy Transition Partnership, and so on and so forth. So quite a lot of funding agencies that provide research funding, and we also create a consortia and submit a proposal to this to this call, and we win proposals. So this is 1/3 of the funding bulk, yeah. And then the other 1/3 is coming from private contracted research. So we contract research, or we contract with industries and different companies, technology companies, to help develop a prototype for them. So they may not have the expertise and knowledge domain knowledge to develop this prototype. So we develop it for them, and then we hand it off to them, and they bring it to the market.
Okay.
So this is the second funding instrument, or the way we derive funding. So it's the direct contractor research. And then the remaining 1/3 is funding from the government of Austria.
Okay.
So this is fixed funding that we receive every year from the Ministry of Innovation of Austria.
Yeah.
And this enables us to do a lot of supporting work for the first two. So all the background research that needs to be done that cannot be funded from the European Commission or from the Austrian funding agency is done with this.
Yeah, this is something that we discussed before recording. It's you are bridging the industry with research and academia, so it's amazing.
Absolutely. So AIT is we work as a bridge between academia as well as industry. So it's really bringing all the low TRL, low technology readiness level research so that universities develop. It's very innovative ideas that they're developing. So we bridge it. So we build a prototype, or we build a concept that goes beyond the low TRL research, so that the industry can adopt it and bring it to the market.
Amazing. And maybe something that you have done in this research, if we can go to the CEE region, how do you see the... have you done some research in CEE, actually?
Yeah, I mean, so we have multiple projects, yeah, absolutely, that we have worked with the partners from the CEE region, for sure, Austria, Central European, and also Eastern European regions, yeah, absolutely. Okay. So we have partners from Romania, Czech Republic, Bulgaria, absolutely. Yeah.
Okay. And what kind of projects and what have you seen there in these countries?
Yeah, so the European grid is one grid, so it's a single grid across Europe, and the challenges that we are facing, everybody's facing across Europe. Yeah, from Northern Europe, from Finland to Portugal. Yeah, so this is one European grid. Of course, there are specific national level challenges that different countries across Europe have, especially in Eastern Europe. We could look at the energy mix, for example. It's more carbon-based compared to Austria. Austria is strategically located in the Alps, so we have a lot of hydropower and a lot of wind right now, so that's an advantage. But I think there are countries in Eastern Europe that are still transitioning to renewable energy at the moment, and the progress is incredible. I think
very fast.
Yeah, a lot of countries have really pushed towards large-scale implementation of renewable energy projects. And of course, they will now start facing all the challenges of this new integration of renewable energy that we have already faced in Central Europe and Eastern Europe, like 5-10 years ago. So all the solutions that can be developed and tested, actually quite well tested, can be easily implemented in the Eastern European regions.
Can I add just one thing? Short answer, because Raul is. Now, we also see this knowledge gap between Eastern Europe and Western. How do you see that it could be better, this knowledge transfer with those professionals? And
I would say to create more projects, to create more consortia together with the research entities, universities, industry partners from Eastern Europe to share knowledge. Because I think working in a project together that's funded by the European Commission or anybody else, it doesn't really matter, is extremely advantageous, because we learn from each other, because we attend meetings together. We have brainstorming meetings to really discuss all the issues that we have and then find a unifying solution. So I think that's really, again, I'm coming from the research point of view. Of course, from the commercial point of view, there are different ways to do this, but from the research point of view, it's really to collaborate and then exchange researchers. So we from AIT go to a university in an Eastern European country or vice versa. And that's how you build this collaboration. Yeah, absolutely. Yeah.
Bharath, you worked a lot with energy communities as well, designing energy communities, and I believe you were telling us that in 2018 you already started working on that. Tell us a bit more about what exactly energy community means and how you design them and what's the benefit of it.
Absolutely. So in 2018, and I think, I don't remember exactly the date at the moment, but European Commission adopted officially the clean energy package, which for the first time put it in law what an energy community is. So there are two kinds of energy communities. A renewable energy community and a citizen energy community.
Okay.
So this is fully defined already. So a renewable energy community is a community that is local.
Okay.
So it depends on the country, of course, and how the regulations are transposed, but it's local. So it's one street or one small village, and if you look at the power grid, so it's usually a one feeder or multiple feeders together are in one community. So this is a legal entity, by the way. So community is a legal entity.
And
so
anyone can start it?
Anyone can start it. Anyone can be part of it. So there is, of course, there are specific requirements, but generally, yes. And in citizen energy community, it's not in one location. It can be anywhere in a country.
Okay.
So if you are living in Vorarlberg, I'm living in Vienna, so we can create an energy community together called a citizen energy community, and we can share energy. So in Vorarlberg, if you're producing a lot of photovoltaic power, you can sell it to me in Vienna. So it's independent of the location. So it can be anywhere in Austria, in a particular country. And of course, across Europe, this transposition has happened in different ways, and it's still happening.
Yeah.
So currently, I'm developing a study for the European Commission, DGNR, on exactly looking at the current LEC ecosystem across Europe.
LEC, what is that?
Local energy community ecosystem
local energy.
across Europe, to really check what's the current status of this transposition, of the EU level regulation into national laws, to see how well it has happened. So for example, in Austria, it's fully done, so it's been fully transposed. Of course, there are some challenges that we're still trying to address. In some countries, it's not fully done, so there's only certain parts of it is done, and in some countries, it's absolutely not done.
And Austria has a lot of energy communities coming up. Why is that, and what are the enabling regulations for it?
Yeah. So it's mainly there is this incentive to create local energy communities because of the prices. So a couple of years ago, due to war, you might already know that the energy prices were rather high during this time, and there was a lot of investment in photovoltaic generation across Europe, mainly Austria. So there's a bit of a panic buying of PV plants, and that's the reason if you have a photovoltaic panel, and you would want to also provide this energy to your family members. So that's really the main initiative, the main incentive. So you want to provide your, for example, parents living in the countryside. They have a lot of space. They have rooftops that they install PVs with, and then there's a lot of excess energy that they don't use. So they'll give it to children in Vienna. So that's really the main focus, I would say. A large number of energy communities are owned by a few people in Austria, a handful of people. And of course, there are bigger ones right now, but the incentive is that they want to share energy across the community.
But do you think that energy communities will play a role in demand response side in energy transition?
Right. Yeah, that's a difficult question at the moment to answer because the regulations are very stringent. So right now, there are very few countries across Europe where local energy communities can provide flexibility to, I don't know what, to the grid or to an aggregator, and finally the aggregator goes to a market. This is not fully defined at the moment.
Okay.
Yeah, but there is an interest, at least from the European Commission, to see how this could be done, and that's the reason the study that I'm doing with DGNR is also looking at flexibilities, and how what could be the enabling barriers or enabling conditions and barriers for flexibility inclusion, flexibility extraction from energy communities.
And do you think there could be, it should be done more in the fossil dependent countries in the Eastern European region, such as Poland, maybe?
Right. Yep.
Should be done more there?
Yeah. So from a power system perspective, fossil-based generation, especially synchronous generators, are from purely power system perspective, they stabilize the grid way more than renewable energy, because renewable energy is more independent in nature, and it's not easily controllable. So if you have a lot of fossil-based generation, you don't need a lot of flexibility.
Okay.
Yeah.
You have it.
That's the reality. Yeah, I'm giving you guys straight. Yeah, that's how it is from the power system perspective. But that's not what we want. So
Yeah,
we don't.
exactly.
We are okay. I mean, we're willing to sacrifice a bit of control to increase the share of renewable energy. And renewable energy goes hand in hand with flexibility.
Yeah, and well, this is the friend that you don't want in the room but is needed. Do you think that gas will play a role in the next 10, 15 years?
Yeah.
Or
I mean, gas will of course continue to play a role, because the transition from again gas-based heating mainly to electric-based heating is happening right now, but it takes time, right, to replace all the new houses that are being built in Vienna have to be electric heating, or they're at least trying to do that across Austria as well. And all the new constructions, they're of course going to be electric based, but there's still a lot of houses that have gas heating. And then it takes a lot of time to transition this to electric, and it's a long process.
But not in heating, I mean not only heating, but in electric generation. Gas will play a role in this flexibility?
I mean, this is anyways not a lot, especially in summer, because like you mentioned,
summer,
negative pricing, so there is not a lot of gas generation anyways in summer. In winter, sure, there are still gas power plants that are active in Europe, but not a lot.
Okay.
So I don't think gas is going to, again, from the electricity point of view,
Exactly.
not a lot.
Okay.
But heating, massive. Massive.
Rahul?
Amazing. And because we saw all the work that you have done so far, you also designed some P2P market.
Yeah. This was part of a project called Blockchain Grid project.
Yeah.
This was, I think, finished, was it 4 or 5 years ago? And this was again during the whole blockchain hype. We wanted to see if it's possible to create a peer-to-peer energy market within a community in Steiermark. So this is actually a real village where we deployed this market, and there all the customers who produce electricity can sell this to their neighbors with the help of the blockchain. So we have smart contracts. It automatically computes how much you're producing and how much you're feeding into the grid, and you can virtually sell this power, and you can earn cryptocurrency.
And what was the outcome of the study? Is it possible?
Yeah,
or?
so the main outcome of the study is you need to automate it.
Okay.
Automation is the most important thing, because these are microtransactions. Unlike the European level or country level markets, you can't preemptively manage this. So it needs to be done automatically. Yeah, that's the main outcome. And of course, blockchain is losing its edge at the moment, at least in energy. There's not a lot of funding and not a lot of interest in energy in blockchain. So yeah, it's dying down, I would say. Yeah, we're at the end of the whole blockchain implementation, but there's still a lot of proponents of blockchain who really believe in it. But we will see how it goes. Yeah, that's what I can say at the moment. Yeah.
For now, we'll leave it to the crypto guys.
Yeah, exactly.
Hey, we were discussing about the role of academia and industry collaboration, and AIT is doing it wonderfully. And we saw that you are a research scientist, also a business developer. You're contracting with bigger industry companies. Tell us a bit more about how you collaborate with different stakeholders and what you have to do to get all the research going here.
Right. Yeah. For the first part, for contracted research, so it really depends on the client's requirements. Yeah. So we have a large collection of solutions that we have developed within AIT. So it really depends on the requirements of the client. So we have control engineering expertise. So we have a lot of algorithms, a lot of prototypes that are controllers for distribution grids. Again, of course, AIT is quite wide, but I'm really narrowing it down to digitalization and power system applications here.
Sure.
So we have things related to AI applications. We have a lot of advanced forecasting methods, state estimation methods, predictive maintenance methods that we can provide to solution operators, the companies which develop SCADA systems, for example, the companies which provide solutions for local energy communities, for example. So all of these are our clients. Okay. So we develop this based on their needs, and then we provide this prototype to them, and they need to put a lot of effort, of course, to bring this to the market and make it more viable in the market based on their own requirements. Okay. So this is the first stream. Yeah, this is really a client relationship, AIT client relationship, and then we develop this exclusively for them. Of course, the funded research is more broad. We have a lot of consortia members, and we have consortia members who are from industry, from academia, from research, with different set of exploitation criteria that they need. So universities mainly focus on publications. They don't really care about software solutions, for example. Industrial partners, they care about software solutions, but we need to test them in the relevant environment to make sure that they actually work, and then they can take it away. So there's another exploitation plan. So it's very customizable. It's very diverse. So that's the key here. Yeah, and of course AIT is also doing spin-offs. Those are helping spin-offs, and we have different models how to transfer the IP, the intellectual property that AIT owns, to the startups.
That's great. And we were discussing, Daniel, about also how successful spin-off gets to the market, and also about time for them to get into the market. Tell us about some successful case studies that got.
Yeah, absolutely. Infrared is one of the highly successful spin-offs from AIT. So this startup is coming out of the group of Digital Resilient Cities. DRC is also part of Center for Energy, and they're developing AI tools, visualization tools, showcases for city planners. So if you want to plan a city, if you want to make it more green, you can, in no time actually, with virtual reality, you need to wear some virtual reality glasses, and you're able to build the city with different stakeholders. Wow. So you can contact different community owners. You can contact people who are interested in making the city more green. You can bring just general public into this design process and really see what they need actually. And based on this, you can design this city, or a portion of the city, or do renovations for the city. And then, so you can develop detailed plans out of it so that the builders know exactly what to build.
Okay, amazing. And what are your next research? How do you see the next 5 years?
Definitely AI applications for sure. Yeah. So the current research interest for me is to minimize the amount of time it takes to connect a new power plant to the transmission or distribution grid. Okay. Yeah. So if you are, for example, Rahul, you are interested to build a wind power plant in Lower Austria. So you are able to convince some venture capitalists to give you some funding to build this wind power plant. But the problem is you should be able to connect this wind power plant to the closest medium voltage or high voltage feeder. This connection takes 9 years.
Wow.
So there's a queue. Yeah. So there's a queue. So you need to get on this queue even before you start building anything. Okay. So it takes about 9 years to actually to be able to connect this plant. So in the meanwhile, if you're already finished with your plant, so all the wind turbines are already up and it's spinning already, but you can't connect it.
Energy.
Yeah, you can't connect it.
So what do you think that it can be solved? Is a regulatory challenge, or?
It's both. So of course there's very stringent regulation on exactly how to connect this, but there's also a lot of power system simulations that we need to do to be able to provide this test report. Okay. And make sure that the wind turbines or whatever generation that is connected is actually capable of following some parameters that they need to follow. And we are trying to address this with AI to make it more fast, so that we want to reduce this 9 years waiting time by a factor of I don't know how many. So still the research, but whatever it takes. I mean, there's approximately 15 terawatts of renewable energy that is sitting in the queue right now. Wow. 15 terawatts.
We're going to stay aware what is happening with this study. Will be interesting.
And Bharath, just about, so also with research, what happens that if it's taking too long, it becomes redundant in the market. So
absolutely.
how do you make sure that the research is up to date with the market and what's needed in the market?
Absolutely. Some of the research that we do is quite ambitious. So they're already 10 years beyond state of the art.
Yeah.
So then we have enough time to catch up. At least the solutions, we can catch up and bring it to the market. But there's some solutions which are maybe 1 year beyond the market or 2 years beyond the market. And then these research projects are very, very long. So European projects are 4 years. And yeah, I completely get that the products or the research that we do at the beginning of the 4 year, but at the end of the project, it's already obsolete. And that's the reason I think we should really focus on creating more agile project management style. So I think agility is super important in research, and this is not currently being done. So this is something that I'm pushing as well within our group to make it more agile. So we want to have a minimum viable product, maybe the first year, and already try to look at exploitation with the industrial partners part of the project. So that's one way.
Do they function as a startup or already, or that they need to get into the market, they need to be adapted to the market, or they are more orthodox in the research way, first they get the research on board and then, but how do they function now?
Yeah, there are different methods here. So we can either, so the IP that is generated within the project can be adopted by the industrial partner already part of the project, or we can go for a startup. So both is possible. So we can either just license the solution that is developed within the project to a partner, an industrial partner, and they use this license to develop it further and bring it to the market, or we go for the startup route.
Yeah.
And it's also possible to put this startup plan already part of the proposal for the research project. So Europe funds this. So EU funds all the prerequisites to fulfill all the prerequisites for the startup as part of the project.
Okay. And
this is not being done at the moment, so there's such a huge gap right now, and nobody is really utilizing this opportunity.
I think that's where AIT is really the bridge, and then they go out of the system of AIT, or they are still within the.
They will go out of the system of AIT because AIT will help with all the knowledge transfer, IP of course, and all the initial steps that are needed to establish this entity, this independent entity or a startup, and then this will be out of the AIT ecosystem.
Okay.
Right, so the invitation is for the industry to come here and collaborate, right?
Yeah, absolutely.
And then they can raise money once they are out of the system. They can get into the VC money because before that it's funded money from the
exactly. Yeah. So once the independent entity is created, so they can it's out of AIT ecosystem, so they can raise money and then they can develop the product. They can do whatever they want after that.
And do industries? Sorry, there's just one more question about it. Do industries already, because of your partnership, they take it to scale?
Yes, this is also possible. We recently had a conversation about corporate venturing, or corporate clienting as well. So if there is a particular industry which is very niche and they're looking for a very niche product, then we develop it together within a research project, like we always do. Funded partially by public funding from research calls, basically, and then the startup is created. And typically, big companies, they do not want to assume the risk of this very innovative new solution, and that's the reason they do corporate clienting. So you have a startup that is a direct client, or the single client of the startup is this big industrial partner.
Okay.
They fund that, and then they're able to scale it up rather quickly.
Okay, amazing. Well, maybe to be closing from here, AIT Labs, you can see hear the noise of the like feeling here in the lab. So maybe what would you recommend to future professionals in energy field, researchers, to get into this energy transition flow?
Yeah, I mean, absolutely. I think the most important item that you need to do is, just get up and then go around, talk to people, And then you can do a lot without formal education in power system. So formal education in electrical engineering or energy system. So you can do quite a lot, because the energy transition is not a problem of engineers. It's the problem of citizens.
Wow.
So it's anybody who is a citizen of Europe or across the world is involved in energy transition. So it's everybody that needs to stand up and push for renewable energy, push for more green solutions across all the sectors, not just energy, all the transportation sector, which also needs to be transitioned to renewable energy, basically all the sectors. Yeah. So I think that's the most important thing.
Wow, that's a great statement.
Yeah, for sure. And also, since you are doing it successfully, what would you tell others why it's so needed to bridge academia, industry, and research together? I mean, how can also it be successfully replicated by others?
Yeah, absolutely. I mean, it's super important to bridge let's put it this way, all the stakeholders in the technology readiness level. Mm-hmm. So where universities are at the lower end of the spectrum and industries are at the higher end of the spectrum. Mm-hmm. It's very important to bridge all of the entire spectrum, because all the innovation, like all the amazing ideas, concepts are developed at the university. And the only way to bring this to the market mm-hmm. is that we have a bridge between all these different stakeholders along the technology readiness level. Because industry wants something that the universities have exactly. or that they're coming up with. But it's an extremely high feat to bring whatever innovation that this brilliant minds they come up with to the market.
Theory to reality.
Theory to reality. So this is extremely challenging. Mm-hmm. And that's the reason we need to work together to involve multiple partners along the spectrum to push the solution from theory to reality.
That's what we are trying to do, to bridge all the stakeholders. So thank you very much for receiving us here in your lab. I think we're going to come again.
Absolutely, hey, welcome. Yeah.
Because we went to the other lab with DC solutions and trying and pushing until the limit the
why
protections.
Not we just go there now and ask a couple more questions on the way. Yeah, let's do it.
Let's see.
Yeah, that's good.
Okay,
yeah.
So. Okay, so we came here to the other lab, and now all this equipment is to test DC.
Absolutely, yeah.
Right? So,
Could you tell us a bit more about this lab and what happens
here? Yeah, sure. So this is our brand new direct current laboratory. So this is the DC cube. So that's what we call it. Uh-huh. So it's a bank of rectifiers, basically. So diode bank with a rectification element to it, and we can test the protection devices, basically. So that's the focus of the lab. So DC protection devices in the laboratory with very high current values. So that is what we want to do. So we want to pass very high current through the protection device and make sure that it adheres to the standard.
Amazing.
That the devices are supposed to be doing. Yeah.
Actually, last week we went to Intersolar and we realized that there are starting to be more DC solutions to avoid the inverter and just going from the PV, DC bar, and then superchargers or DC loads.
Electric vehicles, for example,
So how do you see the current DC use in electric current?
That is the next step, actually. So you're absolutely right. So we're trying to transition from converting from DC, so a lot of DC, renewable energy is DC mainly, to AC and then back to DC. So we can do basically everything in DC right now, because a lot of electric vehicles are, actually all the electric vehicles are DC, so you need to lose some power there in losses.
AC and then DC.
Exactly, and that's the reason DC devices are getting a lot of attention right now. Mm-hmm. And it's going to be increasing for sure in the next coming years. DC is going to be one of the main topics, and especially when there's renewable energy, you want to stay in DC to avoid losses.
And we heard some noise. What kind of testing is going on?
So right now, the colleagues are clearing up, I think, for performing the tests. So
Yeah.
this is a commercial laboratory. So we have clients bringing their devices here to this lab to be able to
To be destroyed, actually.
to be destroyed, yeah, to be destroyed, yeah, so that they adhere to the standards that the devices are supposed to be.
And then you certify them.
No, AIT doesn't certify. We provide a test report.
Yeah.
So that they can take this to the certification agency, and then of course the agency looks through this report, and then they certify the device.
And you said most of the clients that are coming are from Korea and China.
All over the world, yeah.
All over the
All
world.
over the world. Absolutely.
And AIT is one of its kind who does this report.
For Austrian ecosystem, so we're in the smartest laboratory.
Yeah.
That's, I think, one of the only ones in Austria which provides this test reports for inverters mainly. And this is one of the very few, if not the only one in Europe, which does high voltage or high current DC testing.
Okay, and there were DER labs that you mentioned there. About how many of them are?
I don't know the current number, so probably 30 labs across Europe.
Okay.
The DARE Labs initiative.
Yeah, just to make a context that this is an association to coordinate all the labs across Europe.
Yes,
Right? So
absolutely.
to know overlap work
Yeah.
and if you can tell us a bit more about it.
Yeah, so DARE Labs is a European initiative it's an association of all the research laboratories, mainly on renewable energy across Europe. So we have members from basically all the countries, and the goal was to establish cooperation between research institutions so that we don't develop similar competencies. So we don't want to overlap our competencies, so that we don't basically waste funding because it's a lot of funding that's being used to develop this, and it takes years to develop, and we don't want to wasted by developing competencies and compete against each other. So we want to complement each other, so I think that's the reason. So if you have a client with a particular product, so they can go to their lab consortia, and then they can ask which laboratory can do this testing, and then their lab will send it to us or to any other research laboratory across Europe.
Okay, maybe we could reach them.
Yeah,
Totally,
sure.
yeah. I can put you in touch with them.
I mean, Daniel is electrical engineer, so he understands everything already. But what's there? If you could explain a bit.
Yeah. So this is the DC
I will
cube.
show a bit.
Yeah, we can go inside.
Yeah.
Okay, wow, let's go. We're improvising here. And okay, amazing. Wow. Okay, so
here.
Put it here and
okay, we still have batteries, so we can do something.
Yeah, so the main goal of the DC cube is to convert electricity from AC, alternate current, to direct current. Here we have a rack of diodes, which does that in a in a rectification fashion.
yeah,
Wow, this is our
So you have different diodes,
yeah.
Wow, I cannot move here. Yeah.
and this is fully customizable. So we can get multiple combinations of voltage and current. So we can have very high current application, we can have very high voltage application. So this is fully customizable.
Wow.
This is all copper, and then there are transformers right above.
Wow. Super. Do you have more questions, Raul, of this?
Yeah, I'm just actually very amazed. I feel like a kid, but it's interesting. And also, if we can go where you blow up.
Yeah, sure.
Wow, yeah. Oh, this is so amazing. Wow, now we are walking through the lab.
The external test chamber.
Okay.
So this is the external test chamber.
So here you make the test to blow the... This is for the protections, right?
Yep, exactly.
Amazing. So
fuses, protection devices, relays, circuit breakers, so on and so forth.
And
Okay.
how often these tests happen?
Quite a lot. Right now it's very busy, and that's the reason we are here super early. Otherwise, this would already be starting.
yeah, we came here super early just for the note. It is amazing. It's worth it. Okay, so it has been amazing being here. thank you very much for
absolutely.
having us. And yeah, I think we can come back for more,
Yeah,
more
and
insights.
it's really cool. I mean, especially thank you for taking us for the spin in the lab, because being in the office is always fun, but it's about people behind the energy and also in the environment that they work in.
100%.
So thank you, Bharath.
Thank you so much.
It's been a pleasure.
Thank you very much,
Thank you for
and
coming.
probably see you again.
Yeah, absolutely.
For another interview.
Yeah,
so,
definitely.
thank you for the community for watching the interview, and stay tuned for the next episode. See you there.
Ciao, guys.
Ciao.